So it's my honor to get to introduce a person that you all know, the Space Technology Mission Directorate Associate Administrator, James Reuter. James was named the Associate Administrator for this Mission Directorate in June of 2019. And it's a position in which he served in an acting capacity since February of 2018. And in this role, he provides executive leadership and management of the broad set of technology programs within the Space Technology Mission Directorate, which now have an investment value of well over $1 billion. I'm going to come back to that. Jim was the Deputy Associate Administrator for the Space Technology Mission Directorate prior to that. And prior to that role, he served as the Senior Executive for Technical Integration at the NASA Marshall Space Flight Center from about 2009 to 2015. He's actually served in a broad set of managerial roles at Marshall, including as Ares Vehicle Integration Manager in the Constellation program, as the Deputy Manager of the Shuttle Propulsion Office, and the Deputy Manager of the Shuttle External Tank Project Office during the Space Shuttle return to flight activities. He began his career as an aerospace engineer at NASA Marshall in the Structures and Propulsion Laboratory after earning a bachelor's degree in mechanical engineering from the University of Minnesota. Jim's received a large number, a broad set of awards and honors over the course of his career. The two that I wanted to highlight are in 2019, he received the NASA Distinguished Service Medal, which is the highest honor recognized by the agency. And in 2016, he received the Outstanding Leadership Medal. Now, some of you know that in 2010, 2011, I served as the NASA Chief Technologist, and at that time, I had a role somewhat similar in a startup mode to Jim's role today. Jim's responsibilities far exceed what I was dealing with at that time. But the thing I wanted to say is, back in those days when the space technology programs were being stood up, we were hoping to get funded at about $500 or $600 million a year, and dreaming of the day when we would get funded at perhaps $1 billion a year. And so to me, over these last 5 years, when space technology has really come into its own, it is an established, recognized, firm part of NASA, and it has a stability to it now that it didn't have back in that time. And I think Jim should, gets a lion's share, frankly, of the credit for where space technology is today at a budget level of around $1.25 billion with a stability of purpose and a stability in budget. And that takes a broad set of acumen and a lot of leadership talent. And so on behalf of everyone here, Jim, I just wanted to thank you for that. And I want to ask you to come on up. We'd love to hear from you. Jim Reuter. Thank you.
Well, thank you, Bobby. That's really too kind. And what I would say to that is, I've started up major programs. I've started up, major projects, that sort of stuff. Starting up a mission directorate from scratch, that's a real challenge. And what I'd say is it's a testament to how well it was done is we basically didn't change the structure. We've grew it. We looked at different opportunities. We tried to be innovative about how we're doing things, but we really kept the structure pretty much the way Bobby set it up. So we really appreciate the great work he did. And what I'd say, it's really, really great for me to be here today. It's awesome to see such a large audience, and then we have an overflow room as well. And it makes me think, we started up the Lunar Surface Innovation Consortium. It was an idea back in 2019, so it wasn't all that long ago. And during that time, we said, well, let's get some consortium. Well, we didn't even know what to call it. We settled on consortium, and let's get people together to have a real communications, because if we want to have a sustainable presence on the moon, well, the way to do that is engage the entire country. And really the entire world. So we stood up this consortium, the LSIC, and we thought we could probably get there, but I really didn't think we'd be able to do everything we did. That first day, that first kickoff, which was February 28th, 2020, and we all know what happened in March of 2020. But so it was just starting off with this. We brought in APL. They've done an outstanding job getting us here. And we have now, since then, had, I think it's this our seventh time, seventh of these meetings that we have. And now we are up to the point where we have over 750 organizations that are actively participating on a monthly basis. There's all 50 states represented. 48 countries are part of this right now. The District of Columbia, several of the, what am I trying to say? Oh, well. Anyways, so we've had thousands attend our biannual meetings. The first time we did a survey, and over half the people had never worked with space tech before. In fact, probably a lot of people in this room and stuff, even our host didn't have that much for it. It's really going great. And I really want to thank Johns Hopkins University, the Applied Physics Lab, for hosting us today. The outstanding job that our folks at NASA do with the folks at APL that put this together, just an outstanding job. I can't say enough about it. The web page that we have, the access to information is just outstanding. And so with that, though, I thought I just have a few minutes, and I'll try to talk a few things that we're doing now. Where do I, there. Anyways, just a couple charts here. I know we're running a little short on time. And we often talk about our space technology framework that we've been building. That framework was really dovetails very nicely to what Spuds talked about at the agency level, the objectives we have, lunar infrastructure, transportation. When you look at those things, there's a lot of places that we're touching. And so we have that framework, and I didn't think I'd talk about it this time too much, but I did want to talk about kind of our basic fundamental charter. It's the pillars that Spuds talked about, and for us, our really ultimate objective as a mission director is to ensure American global leadership in space technology. And with that, we want to do three key things. Advance U.S. space technology innovation and competitiveness in a global context, which includes our own missions at NASA, which includes other government missions that we have, and as we go through it. And the second one is to encourage technology-driven economic growth with an emphasis on the expanding space economy. A big part of what we do is to help expand the U.S. space economy as we go through this. And then finally, to inspire and develop a diverse and powerful U.S. aerospace technology community. So if we're going to be sustainable, Inspire has to be core to that. Spuds was so nonchalant about this. I'm really impressed. I can never handle it. Where do I point it to for next? Okay. The window. The people that have the camera shining on me. Okay. I don't have a huge amount of time, but we wanted to just touch on some of the highlights, just things that are going on right now. And so I'll go through them fairly quickly, just to give a sense of the breadth of what we do. The top left item is the Lofted. We named the mission dedicate the mission to Bernard Cutter from ULA. That mission was extremely successful. Demonstration of a 6-meter diameter hypersonic inflatable decelerator. If you're going to go somewhere with atmospheres like Mars, back to Earth, you really need create a large drag area. The best way to do that in a small package is to have an inflatable. Well, that mission flew on the JPSS-2 mission in November and was almost virtually flawless. And there's strong interest not only in NASA's missions for us landing to Mars or even returning to Earth, but also from industry. There's actually a very strong push for it. And that's what we try to do, is any of the places where we can check off a couple boxes at the same time. That's great. Capstone mission, you may be aware of. It was a 12U mission about the size of a microwave oven that has entered into and very successfully operated in the near rectilinear halo orbit in front of the gateway system. working extremely well as we're going along. T-Bird, the upper right, was a small, very small spacecraft. I think it's about a 6U that's demonstrated, I think, the fastest downlink speed now on optical communications, 1.4 terabytes over 4 minutes. Solar electric propulsion, we've developed the large electric propulsion thrusters that are going on the Gateway power and propulsion element, and they're have entered qualification testing. The flight units are very well along the way as well. The rollout solar array is a great infusion path. It started with 19 SBIRs, and following that, a game-changing development of a large-scale system. It was a good idea, rollout solar arrays, and now it's finding its way in many locations. In fact, it's the replacement arrays on the ISS. It also has flown on the DART mission. It's the solar arrays that will power the power and propulsion element of Gateway, and other uses as we go forward. MOXIE on the moon, we developed and implemented several technologies that were on the Mars Perseverance rover, including the terrain relative navigation system that helped us land on the Jezero crater. MOXIE is still operating. It's creating oxygen from the Mars atmosphere very successfully. I think we've operated 13 or 14 times now. Let's see, Talos, we developed these thrusters that are now seeing its way into the CLIPS landers. As we go through it, the idea behind this is, hydrazine freezes at just above water freezing temperatures. And so it's very challenging to go through this. The idea behind having a higher oxygen concentration on the oxide for these hydrazine thrusters that we call Talos is we can operate down to like minus 40 degrees or something as we go through this. we just announced a consortium last week at the Space Symposium that we call In-Space Servicing, Assembly, and Manufacturing. We won't touch on that much here, but it's very much related to this, and we're really excited about the interest we have there, and really, especially in this area, this fundamental technologies that we can advance a lot of missions across government agencies. Deep space optical communications, we have what we call DSOC on the Psyche mission that now will fly in October of this year, and it will be demonstrating an optical communication system from deep space, the Mars environment. Cryogenic fluid management demos, I think when I bet over the last 30 years, I've heard multiple times that if we're going to do something, that the time is ripe to really make a fundamental difference in a lot of the way we operate missions by having long-term storage of cryogenics, oxygen, methane, hydrogen, and have a large-scale and demonstrate large-scale transfer of those on orbit. It opens up all kinds of opportunities, and we have 4 flight demonstrations that have in development that are very complementary to each other that we're going on that will fly between 24 and 26. And then finally, TechRise is one of my favorite things we do. I think it's the Inspire things that are always the funnest. But with TechRise, what we have is a grades 6 through 12 competition, and we ask the schools, around the country, if you had what is a 2U? A 2U spacecraft, 4 by 4 by 8 inch, what would you do with it in a suborbital environment? Mostly on balloons, but also on rockets as we went through this. And so then what we've done is we've operated 2 years. The first year was kind of a learning year. The second year we got it nailed down so that it operates in the 1-year cycle of school. So we give a call to the schools in August. They develop their plans. They give a proposal. We make selections in January. We give them the hardware they can do. We give them $1,500 as parts and stuff, so that the different school systems are more challenged than others. And we have a scoring system that tries to balance across the country, so that somebody that's in a small rural area in Arkansas or somewhere else is not competing against Pasadena, California. And as we go through this, and we've now, over the 2 years that we've done this, have awarded 117 awards, and now those, actually very soon now we'll be launching the first ones. And we can do about 30 or so at a time. This summer you'll see a lot of that. So I love the program, and I love doing these things. Rachel, I'm not very good at pointing. One other thing that we've done that you've probably heard that we announced back in January is an agreement with DARPA and NASA to do an in-space nuclear thermal propulsion flight demonstration. So I just thought I'd touch on it very quickly. We teamed to execute an in-orbit flight demonstration of a nuclear thermal rocket engine. It's an interagency agreement. It's it's available in public domain that defines our roles and responsibilities. For NASA, our part of this is to fund and manage the development, design, and test of the nuclear thermal propulsion engine. For DARPA, so that was kind of what we wanted. We want a reactor engine system that's extensible to where we want to get to as we go through it. DARPA is in charge of the overall mission. They're in charge of the overall prime contract that we'll be leading as we go through this. And so they will fund and manage development of the flight vehicle, the assembly, the integration and testing of the integrated system, and launch in-space operations and stuff. So it's our reactor system coupled with DARPA, but it's one team as we operate. Space Force has issued a memorandum of commitment for the launch vehicle and launch support. DOE, National Nuclear Security Administration, is providing the high-assay, low-enriched uranium fuel. And the prime contract is expected to be awarded here this spring, fairly soon. I'll touch briefly on kind of a demonstration strategy. If you look at, it may be a little bit hard to tell exactly how the plans is going through this, but as part of our President's budget request as we issued it, we have an overall strategy for how do we utilize the infrastructure aspects really that Spence talked about on the lunar surface. And really what we have is an idea of over the next decade or so of demonstrating technologies continuously. And while there's a number of technologies that we can do as a subset payload, but here we kind of integrated little lander missions, if you will. The first one is actually what we call it's the second Intuitive Machines mission. Late this calendar year is when it's scheduled. And it's really the first mission that's dedicated to technology items. We have the Polar Resources Ice Mining Experiment, or Prime 1. It'll be a drill trying to mine ice, right? Lunar ice water as you go through it. And it'll be the first demonstration of that as we go forward. We also on this flight have a Nokia 4G LTE communications network demonstration that we'll do. A lot of these things these are all partnership items. In fact, that's really our push as we go through these things. And then on Intuitive Machines as a deployable hopper, the idea behind the hopper is just what you might expect, to hop around the surface of the moon at about a mile or so at a time, go down into permanently shadowed regions, come back out, that sort of stuff. And we're really excited about all these demonstrations. In parallel to that, we really want to look at recovery from both for water and oxygen as well. The regolith on the lunar surface has an awful lot of oxygen with it, and in the process of trying to recoup that oxygen, you also can recoup minerals and metallics as well. So we're very interested in that, but right now those technologies we're doing as ground demonstrations as we're going forward. Then the Viper mission comes along, and we'll use that drill, the Prime 1 drill, as we go through that. The same unit, obviously a second copy of the same design. Then in the mid to late 2020s, we have what are called the CT1 and CT2. That's the designation of the CLIPS mission technology, technology led. And then here what we're doing is we have a lot of technologies. I won't read them all in there, but it's all the same sort of things that Spuzz was talking about, ISAU, power, dust mitigation, and so on. You can kind of read those. And right now we're in that point of formative of, okay, what makes sense out of these two missions, one following the other as we go through it. And then later on we're developing, we talked about the nuclear propulsion activity that we have with DARPA, but we're also developing, in the process of developing nuclear reactor for what we call fission surface power. So the idea being 40 kilowatts units, and with that, team it with an ISRU pilot plant. And the idea of, if we go through this, we really want to have a sustainable presence on the moon. And so the idea of going through this is we can engage, and we engage a community along the way. We have partnerships along the way that hopefully can enable at that point that we'll see where we go, that NASA's not the only customer at least. Oh, it worked the first try. I'm getting better, Rachel. Just a couple other things. I'll touch on this because I think I'm getting low on time. a number of things that we do that are on the missions. We do have, with Astrobotic, the terrain relative navigation that helped us land in Jezero Crater on Mars. An adaptation of that with a couple of the Eclipse provider is being used to guide their spacecraft. We already talked about Talos. We already talked about the mission. So let's see. And a couple other things, video cameras and so on as we go through this. I did want to also talk about maybe shifting gears a little bit for the last couple charts. Our funding opportunities. We have a workshop that we're going to be talking with you, I think, for those that are able to stay for Wednesday's activities. And we know everybody, a lot of people have worked with us or trying to work with us with grants, with contracts, with other agreements. And it can be kind of daunting about the number of different opportunities. Where do I fit in and stuff? So what we're trying to do is we created this tool on our techport.nasa.gov. There's a little booth outside here, and then we'll talk about this on Wednesday. But the idea is to help individuals and organizations search for NASA technology funding opportunities. So please check that out. And there's the QR code as well as to help guide you there. And then one of the items that maybe is kind of I have a lot of favorite things that we do, I guess, but one of the things I really like to talk about is I like it when we try to be innovative as we go through this. And we have this Tech Leap Prize competition. We've had 2 of these before we're getting ready to go a third one. And the idea behind that's really with our Small Spacecraft Flight Opportunities program. And the idea, though, is to look at what's a challenge that we can try to tackle in the time frame of about 10 months or something. Go from idea to flying in a fairly short period of time. We've had 2 of these before that have been very successful. We get some really creative ideas. One was on nighttime precision landing capabilities, and the other one was on autonomous observations, either in an Earth environment or somewhere else. And you can look those up on our website, and they're really exciting things. And so we thought, well, this is a great opportunity. The lunar surface is a great chance to think about things that we can do as a prize challenge. And so we really like to have you help us think about what that next challenge or next couple challenges would be. Just to talk about some recent and upcoming STMD selections, our NIAC Phase 1 awards were to 14 researchers. It was back in January, $2.5 million. Tech flights for 9 technologies from academic and small businesses, mostly small businesses, was January for $6 million. Our big idea challenge that we do annually is grants to 7 university teams. This time in March, it was $1.1 million. We have 2 new space technology research institutes that we named in March. And one was on, let's see, quantum sensing, and the other one is on where's additive manufacturing certification capabilities. Thank you. Yeah, Vickers was here, and so I figured he'd really get on me for not remembering his. But let's see. But anyways, they're 5-year, $3 million a year, so $30 million we've invested in these research institutes, and we have a number of these that are going on. SBR Phase 2, in April, we announced $95 million worth of awards. Our NIAC Phase 2, in April, we announced $3.6 million. Our space technology graduate research opportunities, which is for grad students, it's research grants from us to do work, and we announced in April $4.6 million worth of awards. The announcement of collaboration opportunity is something we say it's April. This is a way of utilizing NASA's expertise, both in engineering and well as facilities that help industry and their needs. So it's no exchange of funds. And the April, what is today? 24th. Today's the day we're announcing it. And so what you won't see, I won't give the names now. Right this morning we're notifying the people there. But the idea this time was we had 2 topics for unfunded Space Act agreements. One is for cislunar lunar surface infrastructure and capabilities, and the other is on in-space infrastructure and capabilities. In-space versus cislunar lunar. 16 agreements are with 12 companies ranging from large aerospace firms to small businesses. The thing I really like about a lot of the partnership things we do like this, what you invariably see is the small guys and the big guys compete pretty evenly. It's not a bias towards one or the other, and so it's really fun to see that. And we're sure that a lot of them are actually very much interested in this. I think tomorrow we'll release the announcement as we go through that. Total estimated value of these agreements will be $14.5 million. Oops, no, I meant to go back, but you got a preview of my last chart. Then tipping point is one that's been open for a little while. We're actually now at the point, and our expectation is the announcement of the awards will be in May, but right now we're within the next week or so is when we'll start due diligence. We've gone through the whole selection process. There's a couple we're kind of still working out. A large part of this is how much funding can we afford to spend on this, and so we have options for not of saying, okay, we know how much this much, but maybe we'll evaluate as the year goes on as well. So I do expect that the company should start hearing within about a week or so. Let's see, and then Deep Space Food Challenge, Phase 2, a really fun challenge. If you remember if you saw what Phase 1 was, it was a joint challenge with the Canadian Space Agency, and it was looking for a lot of different opportunities of how to maintain food and grow food in space. We had Martha Stewart actually announce the winners for us. We had a couple astronauts there. Scott, God, when you stand up here, it's really hard to remember things. So it was a really great competition, and now we're entered in Phase 2. We also have the Civilian Commercialization Readiness Pilot Program of SBR's Phase 2. This is really probably one of our biggest areas that we have with using SBR funding. With matching funds, we can go up to $5 million or something like that. And here in May, we'll be announcing them as well as our SBR STTR Phase 1s. And then finally, just to give you a sense by the numbers of who we are, we, typical year, FY22, we evaluated over 3,300 proposals. We select about 750 of those. We have 1,650 active technology projects with over 900 academic collaborations with over 175 unique organizations. We have over 1,300 industry collaborations with over 700 unique companies. We have over 150 planned flight demonstrations, so about 9% of the projects we have go to flight, currently planned to go to flight. Over 175 patent licenses we issued in 1 year, as well as if you count a transition as being something where somebody else picks up the funding after we've stopped, it's hard to track that, so that number is certainly smaller than it actually is, but we have over 1,000 transitions. It takes a little while, so since in the last 12 years or so. And with that, I think it's time for us to kind of go towards the question and answer phase, I believe. And I'm looking forward to sharing the stage with Spuds and Nikki as we go forward and address questions that have been posed through Slido. And I should say, I think, so to make sure Rachel would have really gotten on me if I had forgotten this. She's pretty much a slave driver too. But so if you scan that QR code for questions that we want for tomorrow's going to be a really exciting morning as we get the heads of Deputy Administrator for NASA, the Administrator for DARPA, OSTP from the White House, all together talking on collaborations as we go through it. So if you want to ask questions, please go to this to this site here for it. And then with that, Rachel, you going to move us over?
Thank you so much.
Thank you.